So what I'll do is I'll start with a very, very quick overview of the upcoming BS in Electronic Systems program. I just have a couple of slides which captures the big highlights. We have shared this information a couple of times earlier during the launch event and last couple of weeks ago as well. But just to reinforce the salient points. I'll share my screen now. Can you folks confirm that you're able to see this?
Yes, we can.
Yes, okay. Great. So I have just a couple of slides giving the overview of the program, and then I will kind of have a conversation with Dr. GV. So this BS in Electronic Systems was launched very recently, and the really important points that aspiring students should note is that the program is actually open to practically everybody. So the basic idea is that you need to have a 12th standard or equivalent with maths and physics at the 12th standard level. If you have that, if you have completed 12th standard equivalent maths and physics, 12th standard and equivalent with maths and physics, you can apply for this program. And once you apply, you have the first 4 weeks of content that is available to you, and you go through that content for 4 courses. And based on that, you do the assignments and write an exam at the end of 4 weeks. That will act as the qualifier. So those who have submitted the assignments and do well in the exams can move on to the next stage. Now, this program has several exit options. So, for example, there is a certain point after a certain number of credits. So this is about 9 courses. The students can choose to exit with a foundation certificate from the IITM code section, or the student can choose to continue on with the program. And the next exit option is at the diploma level, and where the students have completed 86 credits. And at that point, they get a diploma in electronic systems from IIT Madras. Or the students can choose to continue to complete a 4-year BS degree, Bachelor of Science degree. And at the end of completing 142 credits, they can exit with a BS in electronic systems from IIT Madras. And at that point, they become degree holders. They become holders of an IIT Madras degree. They become alumni of IIT Madras. If you look at this program, it is primarily targeted towards producing skilled graduates in electronic systems to meet the growing demands of industry. And we do place an important emphasis on making sure that the graduates of this program are going to be appropriately skilled. So we need to make sure that the students not only get the basics of electronics, but they should also gain foundational and advanced skills that the industry requires. So that is important, and we have tried our best to match our program with what the industry needs. And as I pointed out, there are several exit options. So people who join from 12th standard who want to do a 4-year degree can do so. Or if then it is possible that there are people already working in the industry, they want to upskill themselves, they can choose to do the 4-year BS degree. It is also possible that you might want a specific set of skills which only the diploma gives you, so you can choose to do the diploma and so on. And I wanted to emphasize again that there is indeed no age limit to join this program, irrespective of if you are just out of high school, or whether you have been in the industry for many years, you are welcome to join this program. The theory content will be delivered online, and you can study this program from anywhere. The quizzes and final exams will be held in person at local centers, nearby centers. There are certain number of centers across India where the exams will be held. The lab portion, we expect that some portion of the lab, the more elementary content, getting used to the kids, running simple experiments, can be done by students at their own locations, respective locations, under the guidance of our videos, very detailed videos that we will put out, and discussions with instructors. However, one important highlight of this program is that the more key lab experiments, the really significant, more complicated lab experiments in various hardware courses will be done on the IIT Madras campus. We have created an option for you to choose to be at IIT Madras, visit IIT Madras for 2 weeks per semester, where you will be doing these labs under the guidance of our instructors. So if you want more information, so this is just a quick overview. If you want more information, please do visit our website. The website is up here. It is study.iitm.ac.in/es. And you're welcome to email us as well at the email address displayed on your screen. So that is a quick overview. First of all, I would like to welcome. So we'll move on to the next interaction section, section of today's event. So I wanted to welcome Dr. Venkatesh for joining us today, kindly agreeing to join us today and answer our questions. So thanks, Dr. Venkatesh. So maybe Dr. Venkatesh, what I was thinking was, so the students have also written to us with several questions that they want us to answer for operational. So maybe what I was thinking was, I will ask you a few questions, then maybe I'll answer a couple of their questions.
Sure.
I hope that works.
Sure.
Okay. So maybe I'll start with, with a very, I'm going to stop sharing my screen so that it's easier. So now I'll start with a relatively high level question. So I wanted to get your perspective on how you think the electronics industry in India is going to evolve over the next few years.
So, I mean, the way I see it is, historically, one thinks about electronic systems from the concept of products. That is, you're making an electronic product like a television or a mobile phone or something like that. And then when you look around and see that there are no innovators, we don't have any real product companies in India which are making television. We have assembly companies, but we don't have companies that are actually designing new electronic products in India. Then one thinks, where is the outlet for electronic systems in India actually? But that's not true. The way I would say is that there is a lot of electronics that goes in actually in the industry. Now, even traditional industries, like for example, just to quote an example from my personal experience, I'm consulting with an automotive axle company in Mysore. Okay, it's an American company which has an R&D center in Mysore. So if you think about an axle, it's a mechanical component. I mean, there's nothing. You don't think about it as anything that will have electronics. Is it? It's just a mechanical thing. It has some gears and it has some other things, right? It has some ball bearings. And it's totally mechanical. So what has electronics got to do with it? One would think.
Right.
But then if you look at it actually in a truck or a car or something like that, you have the dashboard. And in the dashboard, you see temperature. You'll see something which says temperature, right? That is measuring the temperature of the engine oil in the engine. Okay? And then you're seeing other things, which are all engine parameters. It's telling you what's the RPM of the engine and so on. There's nothing which is measuring the acceleration on the dashboard. But if you look at the failure in a truck, the engine hardly fails. It's the axle that fails. All right. Now, so the OEMs are worried about this. The company that makes the axle is worried about it. How do you monitor? And in fact, the axle has lube oil inside it. Right? But we're not measuring the temperature of that lube oil. Right? Now we can ask why they're not measuring. The answer is that they're not measuring because they could not find the right instrumentation. I don't know what it is, but they've not done it. So one of the things that we have done, for example, in this, is actually built an instrumentation for measuring various parameters of the axle. It's an electronic system. So you have to build sensors which are inserted into the axle in various places. You're measuring the load on the axle, you're measuring loop temperature of the axle, you're measuring other things, other parameters, whether the bolt in the axle is becoming loose, for example, things like this, okay? And all these measurements, you have to actually innovate on the sensors. Everything requires innovation because the cost is, the pricing at which you have to do these things, costs are so small. There's a lot of innovation that has to go into the sensors, picking the sensors, picking the controllers that you will use, what kind of software you will write, and whether you need this data to be actually sent somewhere else because you may want to do some long-term analysis. And if so, then what will be the communication system? How do you get the cost of that down? How do you make it reliable in the field? Many of the axles that are sent out by this company are into places which are, you won't even imagine the kind of places at which, like mines and so on. So it's very off-road vehicles, very, very tippers and so on, very, very harsh environmental conditions. So all this electronics have to work, the communication system have to work in the most rugged terrains, okay? So how do you do all that? So you find basically even a totally mechanical company actually is now investing in electronics, right? And so there is electronic systems everywhere. In fact, there is another example. If you look, there's some other work that I'm doing, which is about automating the inspection lines. So if you look at inspection, typical inspection thing, there will be, for example, imagine that there's a company that's making metal part with holes in it, okay? Now this hole you have to inspect, you have to check whether the hole is in the right place and it has the right diameter. So what they have typically is that the part comes out, there is a jig. You put this part in the jig, it tells you whether the hole is at the right diameter or not. And if it doesn't go in, either it's not in the right place or it's the right diameter. So it won't go into the jig, okay? And so that's how they do the testing, right? Now, what happens many times is that these components are coming so fast on the assembly line that sometimes they miss some checking of something. So it passes without being checked. And then eventually it will get assembled and then it will go to a customer and then the customer will reject that and it will come back. So there will be returns. So the question really that this company asked is, can we build a visual inspection system which will check whether this hole is in the right place and it has the right diameter? I mean, it looks like a very simple thing to do, but in a moving assembly line to create an inspection system, visual inspection system that can actually take image, consistently take the image. Because even if you have a camera which is too close, it look like the hole is too big. If it's too far away, it look like the hole is too small, right? So the image has to be taken from the right place, right angle, and these parts are moving parts, they're not static parts. It's not at all an easy problem, okay, building an electronic system of this kind. And I'm just saying, like this, there are so many problems in even a conventional industry, I'm saying, electronics-based problems. So that is one. The second is that we have a very large ecosystem of people who are building products for international companies. Either they're doing it out of companies like Sasken, R&D service providers, Indian companies, or we have foreign companies that have set up their R&D centers in India, they're doing their product development. And they require, my estimate is that there are about 700,000, roughly about 700,000, 7 lakh R&D engineers, electronic R&D engineers sitting in these companies, doing all kinds of very interesting products, okay, very interesting designs. And that ecosystem is growing at approximately 10% every year. So we need about 60 to 70,000 new engineers every year to just feed this need, okay? We're not doing any Indian products, let us say, but we are actually providing services, R&D services, design services to electronic design services to, which could be hardware, software, various things, to companies abroad or mostly to product companies abroad. And this could be, a defense manufacturer, it could be a company which is making set-top boxes, it could be somebody networking gear, something like that, all right? Or it could be a power system or whatever. And so these are the kinds of things. So I see that the scope for electronics in India is only growing. I mean, scope for doing electronics, because also many people in the world, they see India as a place to go to for doing work like this, doing software and electronics. Whenever it says electronics and software, people seem to think that India is a good place to go to do it. Okay. So for that reason, I think we have a good opportunity to actually do something significant. Now, this program specifically that has been designed, I see is very interesting because generally somebody who is not very proficient in physics or maths, right? If you're very good in physics or maths, you can generally enter electronics and you feel okay. But if you're not, then you get scared, I think. There's a general fear, okay, I mean, what is this field? I mean, it seems to have everything you see there is some differential equations and some graphs, and it looks very, very, very obscure, right? Like very abstract. So, but in the real world, when we work with electronic systems in companies and so on, there is not that much maths. We are not doing maths. I can hardly, in the 20 years that I've been in the industry, I don't remember ever doing any differential equation solution or anything. Okay, never have done it. So there is none of those is required. So you actually need to get your hands onto a real system and figure out what is going on there and so on. And it looks like we have to. I mean, the program has to be designed in such a way that there is some physics and maths knowledge that is required, but without scaring people, if you can actually give them hands-on experience with building electronic systems, debugging electronic systems, and so on. And I've seen many people who have electronics as a hobby. They get Arduino boards and they get this and that and all kinds of interesting projects. They may not know much physics, right? But they can still do very interesting electronics projects. So if we can develop those people to become good engineers or diploma holders or whatever, I think the industry can absorb them and it will be a very useful thing for the industry.
Okay, it's interesting that you pointed out the theory aspect, differential equations and so on. So we went back and forth while designing this curriculum. So what we have done is there is only the traditional electronics curriculum, let's say ECE curriculum, is such that let's say a PE or a BTech is such that the theory all comes first. And then you move on, maybe the following semester, you do a lab course on something similar and you kind of follow up, you build up on the theory first. We kind of tried in many situations to either do it at the same time or even put develop the hardware skills before we even give them the basic theory about many things. So we have kind of tried to build the curriculum such that, we have a lot of the electronics labs coming up front, even though, for example, they may not learn about transistors till much later. They may not learn about signals and systems till their third semester, but they already start looking at some very basic concepts, things like things in the time domain. From that, we try to teach them a little bit about frequency, even though they may not know it and things like that. We want them to get their hands dirty and start working with electronics even before they hit, because we do understand this is like a primary dichotomy between what is taught in the university and what the industry requires. So yeah, absolutely. So maybe this is a good time actually to get your thoughts on whether there are any specific skills, right, that you feel that a student coming out of the program requires to be successful from the industry point of view.
So, electronic system, if you take, it has many subsystems. So and each subsystem is very different, actually. The domain knowledge that you need to build that subsystem is very different, okay? Because concepts are different, the methods, the kind of devices that you will use to build that subsystem, and the tools that you will use are all very different. Let me give you examples, right? So if you take any electronic system, there'll be something that manages the power, right? So there'll be different parts in that electronic system which will be operating at different voltages. They'll require different currents. They'll be having different power consumption requirements. So you need to have a power management system that will actually feed power to all these things. So how do you design that power management? These days, we are also talking about low power. We want to actually have all these things operate with batteries, right? And you want to make the batteries to last for a long time. So how do you, when the thing is inactive, you want to switch it off, and you want to detect activity and do things, right? All these kind of things. So the power management and with all the electric vehicle and other things requires. So you also have charging. So you have to manage charging, right? And now there is also this idea of energy recovery. You want to recover energy, or you want to generate energy, right? Maybe from something. So it becomes self-sustaining, the whole system like this. So the power management is, so it's its own discipline. It has its own magic. It has its own principles, design principles and all that. So that is one. The other is, every electronic system seems to communicate with other systems too. They are not standalone. So one system talks to other system, one system talks to a system just far away, like a cloud or something. So if that is the case, then basically you need to have something which communicates. So then you have a communication subsystem, and then it has its own logic communication subsystem, how you do that and so on. And then there is another subsystem which is basically for sensing, right? Because you need to be aware of what's going on around you. So you have to sense the parameters around you, and so on. For that you have sensing. So you have sensing subsystem, which also is going through all kinds of challenges, because people used to rely on a single sensor. Now they're saying I'm not going to be happy with just one source of information. I want two sources of information. So I have two sensors, and then I try to triangulate data from these two and do some fusion of these sensors or something like that. And so that means that you don't have just sensing, you have sense making, right? So you're sensing, and then you have fusion of sensors, and then you're trying to make sense out of what is going on. And all this is happening locally, locally in the subsystem. So that makes the system, the sensing subsystem, extremely complex, right? And then you have other subsystems, like for example, you may have a control actuation subsystem, which may turn something on. Based on the sensing, you may want to take some actions, and that can be adaptive, right? So you may not just do. It may say, look at, depending on the situation, I might decide to do this or that, And so, like for example, you have an autonomous driving vehicle, or even just an automatic parking vehicle, just parks it itself. It's such a complicated thing, right? I mean, you can imagine the complexity of it. So, the way I see it is that every domain, every subdomain in this electronics thing by itself is an interesting area to build an expertise in. You can say, I'll become an expert in power. I can become an expert in sensing. I can become an expert just in communication or something, right? Or in control, any of these things, right? And also you can say that, look, I don't want to be an expert in any of these subdomains, but I will be an expert overall. Like, for example, when you try to build a system which has subcomponents which are power management, I buy a power management IC, I buy a communication IC, I buy everything, and then I put it together to make a mobile phone or some drone or some interesting thing, right? So you could say, I don't care about the subsystems. Subsystems have some function, they do it their job. I'm just going to use those subsystems and create an overall system of some kind, right? So you could just be a person who integrates. So I think finally it depends on the the motivation of the individual. If the person is how they are oriented, right? If they are interested in the specific subdomains and the depth to which those subdomains, there much more physics, maths, and all might happen there. But how do I get into the depth of understanding of that particular subdomain? Then they have to go towards specializing in that subdomain. But like become a communication expert, just become a vision expert or something like that, right? Or somebody might say that, look, I don't care for that. I want to solve real world problems. I want to understand how to measure flow in a pipe or something. Let's say, okay. Or there's a canal which is carrying water from one place to another. I want to measure how much water has gone down this canal. It's not an easy problem. Okay, you can try to do with vision, you can try to do with flow meter or something. But where do you place the flow meter? How many of them do you need? So I'll say I'm not interested in how the flow meter works. I'm interested in using the flow meter to solve this problem. So that could be another approach. So I guess there is a potential for various kinds of people to find a place in electronic systems and enjoy electronic systems as a whole, right? Because in everything there is much to learn, a lot of things to learn, and each of these has potential many applications and jobs. There are a lot of jobs in each of these separately.
Absolutely. So I think we did get a lot of questions as well. So related to this, in fact, because they asked us what is the difference between a regular BE or a BTech and this BS program, and maybe this because this your what you said just now really ties into our own vision for the program as well. Because what we have done is we have tried to take each of these. For example, you talked about sensing. We do have a course. So there are some basic electronics courses that kind of in, let's say, analog electronics that kind of culminate in sensors and sensing applications type of course where you deal with transducers and, signal processing, analog signal processing systems. But you also talk about things like the other subsystems, things like communication and so on. So those are aspects that in this program, the student, unlike in a regular BE in ECE, for example, those would all have been core courses, like an analog communication, a digital communication course would have been a core course. In this program, what we have done is we have kind of made them, they will be offered as electives. So the student who is interested in the communication subsystem, so if they are doing it at a very high level, maybe they would pick up an elective such as an IoT elective, for example, right? If they are interested in like large scale, high density communication, or if they are interested in, the ultimate detail of how the communication is done, what kind of communication happens, maybe at the, maybe the signal processing algorithms and so on, there will be various electives. There will be a digital communications elective that they can choose to take. to learn from the bottom up as well. So that kind of ties into what some of the questions the students had about this program as well. So I think one other question I'll just take up from one of the other students. They had written to us. They wanted to know whether, robotics would be a possible option. And that also ties in because you are talking about mechanical systems and how they interface with electrical systems. And I feel that definitely, the students who take appropriate electives, right, in this will be able to target robotics as well as for future research as well as studies. Okay, so maybe I'll pivot to a slightly different question. So you have been part of the, the BS in data science program, right? Right from the inception. So, and you have been teaching as part of that. You have helped evolve its curriculum, some new teaching methods as well, right? So I wanted to kind of, get your thoughts, right, on, let's say this, because many parents and students as well have worries about how online teaching, whether they will benefit from online learning. I wanted to get your kind of input on that, whether how online teaching, how useful it is and how it can benefit them.
So the thing is that online has advantages, it has disadvantages. The disadvantage is that you don't have direct contact with the faculty. So if you have a question in your mind, you can't ask it immediately and settle that question, right? But by and large, if you see most classes that we take with students, nobody asks any questions. So that remains at a conceptual level, that is a problem, but it is not so much of a problem in practice actually. But if you look at the advantages of online, student can go at their own pace. You're watching a video, if you suddenly find that you're not following something, you can stop the video, look at some other material, or even go back and see the same video again, or go to Google, do a search, and then come back and then continue to see the video. You can do all these interesting things, which in a class, regular class, you can't do. So there are advantages, but also, there's a general feeling that online people are not as engaged as in a physical classroom. In a physical classroom, most of the your senses are dulled because everything else is shut out, right? You're sitting inside the classroom, your other students sitting around you, teacher in front of you, imposing structure of the classroom with a stage and everybody is on speeches, writing or presenting or something. That kind of creates an atmosphere where you're kind of forced to engage. Whereas in online, you can be distracted. You can be seeing some internet or something else, and some WhatsApp message may come, you may get distracted and look at it and so on. So there is a bigger challenge in creating engaging content for online than it is in the physical class. Physical class, you can assure basically that engagement is coming as a default. Here you can't assume that. So one of the things that we try to do in the online program for programming and data science is to try to create the engagement through alternate mechanisms, like through a conversational style of teaching. Two people, instead of one person teaching, two people teach simultaneously in the class. Where, like what we are doing now, you basically have an engagement. Two people are discussing, and that's a class, right?
Right.
And so that creates automatically an engaging format, right? A very different format. So it's more engaging for students. And you can do that. And it also simulates question and answer, right? Because when you're doing two people, one person can be asking the questions as if he's a student. And that makes you feel like you're also a student participating in the session and all that. So it is possible, if one thinks through it carefully, it is possible to create in the online format a content that takes away some of the disadvantages of online, but at the same time retains a lot of the advantages that online has, right? And I feel also that, school education is a different thing. Students in the college, they basically are a little bit more selective about what they want to study. You can't can the content and give it to them like what we do in schools, right? In schools, you structure the content according to some plan, and lesson plan, and you teach it and so on. In colleges, you can't do it like that because there are so many different orientations. And in fact, even in a regular program, you have that. But for the kind of program that we are designing here, online degree and all, you will get people from very diverse backgrounds with very different interests, different age groups, right? and different motivations why they're studying this program. For different reasons they're studying this program. Some people are working, they want to learn something extra. Some people are, just wanting to get acquainted with the subject. Some people already know the subject. They want to see how IIT is teaching it. Are they doing it slightly differently? I already know this, but let me see how IIT is doing. So there are different reasons why people come to the program, and their expectations from the program also are very different. So you can't create a very single very strand of the thing, right? So you have to make it in such a way that you leave a lot of open things for them to pursue on their own. So the more you stimulate in some sense interest through the online content, to that extent the program becomes more interesting, I think. And supplement it with a lot of hands-on, like what you're trying to do in the electronic systems thing. So they can do hands-on work, they can come and demonstrate what they're doing and get feedback for what they're doing, that kind of thing. Then I think as a context, if you look at that, that is even more interesting than what you will do in a regular class. Because in a regular class, there is that much less potential for you to do this hands-on work, because the program is already, structure of the program is such that it's already filled with courses, right? There's so many courses, and each of these courses are very demanding. There's so much theory to learn and all that students simply have no time left to do anything else. Whereas here, since we are hopefully creating a little bit more flexibility in the program and so on, so students have a chance to explore their creative ideas, how they implement it with a hands-on kit or something like that, and come and demonstrate it and so on. Yeah.
Okay, so there was actually we had some questions on students asking whether we can do and I'm already involved in a bachelor's program, and I want to take this on as part-time. So I guess our perspective is that this does allow you to do that.
Yeah,
right.
In fact, actually, it's a good idea. I would say that when engineering, for whatever reason, has got compartmentalized into various disciplines.
Right.
And in fact, it's getting super specialized even now. Now people have they're getting a BTech in IoT or artificial intelligence or something like that. Okay.
That's right.
Whereas if you look at any real life job, right, any real life thing, you need to be a little bit more broad-based. You have to understand many things. Like I was describing the axle thing. So you have to understand how axles work, which means you need mechanical engineering knowledge. You have to know how to instrument it. So you need to know electronics. You need to know how to send the data to the cloud and then analyze all those data trains that you're getting from the field to make sense out of that data. That is all analytics, right? So it's all computer science stuff. Yes. So even in that very simple example, you're already seeing 3 different disciplines. Then you take a drone or something like that, right? Imagine a drone. Which discipline is it? Is it aeronautics, which is drone means aeronautics? Is it electronics? Is it software? Is it communications? What is it? So it seems to involve everything, right? It seems to involve, and drones, you have to make lightweight materials, so there's material science in it. So absolutely, today it looks like any real interesting topic if you take up, it seems to involve, it cuts across multiple engineering disciplines. But because our engineering is taught in silos, so it makes sense for somebody who is, say, for example, doing mechanical engineering somewhere, to do an electronic systems course from IIT and get a composite skill, right? A skill which basically understanding of mechanical system and understanding of electronic system. So the combination may become even more interesting for an employer, right? Because mechatronics, if you take anybody who is like robotics you discussed, right? How can you do robotics for understanding mechanical engineering? And how can you do robotics for understanding electronics?
Correct.
Right? So hopefully you are basically building these kind of composite skills. So I think it's a very good idea for people who are doing engineering already also to consider this as a, I won't say minor, but as a dual, another degree, right? Second degree.
Right. Absolutely. So in fact, so we have told people, I mean, whoever has asked us, questions, we have told them that, yes, indeed, you are welcome to, because this program does. So that program allows you to develop the skills, that, the offline program that they're already doing. There are certain skills that they develop with that. And this one, gives you a different set of skills. It might be a different program, or for example, there are probably many students who are already doing a BTech in ECE, right? They also want to get this BS in electronic systems, because one of the things is, we are actually offering courses in this BS in electronic systems that is not traditionally part of the regular ECE program. Things like embedded C programming courses, we have actually placed a lot of emphasis even on, because today, any advanced electronic system has a lot of programming knowledge requirement, right? So we actually have things like embedded software, firmware, things like that. We are giving them a fairly strong base in that, which normally does not form part of a traditional ECE curriculum.
Good point. I think this is another very interesting aspect you brought in, which is that if you look at software, people think about software as some kind of monolith. It's not.
Yes.
Right. There is software and there's software, right? What software goes into an embedded system is very different from software you'll write for web application or something like that. And so traditionally, somebody who is studying software and computer science would not understand electronics. And somebody who's doing electronics will not know how to write software. So there's a problem, right? So we need basically to have people who know how to understand, who have a good understanding of electronics, but who can write code for those systems, right? And
that's right.
So that combination is not that easy to get. Yeah, it's a skill that is not easy to get. Industry finds it very hard to get those kinds of skills.
That's right. Okay, so maybe I'll also cover one other question. I think students from the student side. So they wanted to know about the lab classes. So I just wanted to kind of tell them that they had a couple of questions. So one of the questions they wanted to know is whether lab classes will be conducted during weekends. So really, even for the lab, what we plan is to put out very detailed videos on how to conduct or how to run experiments, the simpler experiments on your own. But we will also have instructors on standby for specific discussion sessions with the students. Now, students, I guess a couple of other students also wanted to know whether it is mandatory to attend every offline practical class, in other words, at IIT Madras. And I wanted to tell all the students that if you are taking that particular lab class during that semester, yes, it is mandatory to attend the offline session as well, because you will be doing the more advanced experiments during that time. So this is for those of you who are wondering about the lab classes. And I guess there is a third question. So the lab, there is a lot of interest about the lab option, because this is indeed new. Unique to the electronic systems. And I think they wanted to know how many days of lab work is required per semester. And that really depends on the specific course. So there may be certain labs which may be simpler in that sense. So let's take a basic electrical circuits lab. Rigging up circuits, maybe simple resistor circuits, resistor capacitor circuits, watching, looking at the transient response on oscilloscope, things like that are relatively simple. The circuits are simple, so there may not be a lot of maybe 2-3 hours per week. And I can imagine the more complicated experiments, electronics experiments, may take more time to debug. Even the digital systems lab can actually get pretty complicated. We get feedback from our own, regular BTech students that, the even digital systems lab. So the digital systems theory course, they feel is relatively simple in the form of theory, but on the lab side, they feel it is pretty involved, because they are building very complicated digital circuits and not just systems. So there are a lot of aspects involved with that.
But I guess here they have the flexibility to take only one course.
Absolutely,
or
that
two
is correct.
courses. So they can take as many courses as the time they have.
That's correct.
That permits. So in fact, actually, that might be better, because if they want to explore that subject much better, they may just take one course and just explore it properly this semester.
Absolutely. Yeah.
And I presume that just like the programming and data science, you're running three times in a year, right?
We are right now running twice a year. We are not running 3 times a year. We are running twice a year, because we need time to run the offline labs.
Okay.
So
2 times a year. So even if 2 times a year, they can do the course anytime. They can do it this time. They can do it next time. Yeah. So there's nothing. They're not losing just because they decide to do it 1 semester later or something.
Absolutely. So in steady state, the operation of the program will be such that every course is offered every term. That is what we envisage. Just like I believe the data sciences also runs in a similar manner. So we plan to do that in the same way.
Then basically, then you're not losing. Just because you didn't take it this term, you're not losing it. We can always take next term. No problem, right?
That's absolutely right. Yeah. So, okay. So I had one more question related to the industry as well. So one of the things we have put into this curriculum, this is similar to the data sciences, I believe. But so what we have done, so we talked to many people in the industry, and we have actually put in an apprenticeship option in the curriculum. So I kind of wanted to get your thoughts on, how this will benefit the students, first of all, and how the company sees it, and in general, why it is important.
So, I mean, for the student, I think they'll get very good exposure to companies' working methods, because getting yourself into a company, an organization, it takes time, because you have to understand there are a lot of things going on inside the company. To understand that itself takes time. Okay? So, and usually if you're in that same industry, if you've worked in one company, that knowledge is useful even if you go to another company in the same industry. So, so getting yourself inserted into an actual company environment for some period of time creates that context knowledge for you, which otherwise you will very hard to get. So that is how I see it from the student's perspective. From the company's perspective, every company has some small things that they always want to get developed. Some here and small things are there. And they can't get their own R&D engineers to do it for various reasons, because they're busy, they don't have the time, or they may not have the knowledge and all that. So in this case, the company would see it like this, right? So there's a student from IIT, right? It's not like anybody else, right? Coming, so you're not only getting the student, you're hopefully getting also free expertise from the faculty who are supporting that student, right? So this is a way to think about it. So without having to give a large consulting project or something like that, if I can experiment with some idea which I have to do, introduce a sensor, or to do some vision, or some other small thing I want to develop inside the company, I get a student apprentice, 1 or 2 people I get, and I give them this project, and then hopefully after my project spec is given to them, they're able to go discuss with the faculty members on a nice solution, come back, try and implement it, and I can give them the resources, give them some working environment, some stipend, something, make them happy. This will work for the company, right? So I have seen that many companies have many projects. I mean, you just walk into a company and start talking to them. If you have some expertise, they start sharing their problems to you, and you suggest some solutions, and then it goes into some discussion, right? And so every company has some small things to do, many things like this to do. And this is, I think, a great step forward. If you can get these apprentice things to work. Yeah, I mean, in other countries, it has worked very well. Germany, for example, it's a very, Japan, Germany, and all these countries, it's a very standard thing, right? I mean, all engineering students go and do this kind of thing in the companies. And that's how they learn. The companies also benefit, student also benefits. So we have to create that kind of culture. I think it's very important.
Right. So I see among the regular BTechs, there is, more and more companies are preferring to evaluate, or rather look at the students much closer through an internship. And then, kind of when they
can recruit them. Yeah, that is, of course, like what is pre-placement offer and all that.
Right.
But, with students, many times they get very disappointed. The reason I didn't mention that is that they go there thinking that that's an entry into a job. Sometimes they don't get the job, and they get very disappointed and disheartened and all that. So you should not see it that way. Of course, may happen, may not happen. But even if it does not happen, what you've learned there is very valuable.
Absolutely, that's
what goes into your resume, and then you can go later. It helps you to find a job, good job. So it is a very valuable thing.
Absolutely. So in fact, we got a lot of questions about placements. So whether whether IIT, rather this BS in Electronic Systems program will kind of, or rather, will there be placement support? Will there be, I guess, yeah. So I think primarily they want to know what are the options of placement, and what kind of companies, whether, so they are kind of used to seeing companies come to, go to different universities and look at, look at placing students from those companies, students from those universities, and they kind of had questions on how placement would work. I think from IIT side, we will we are in the process of setting up a placement section purely for our BS programs, for our online BS programs, so that we have, because the needs of the students are different. The diversity of companies that come for such programs would be very different. The types, numbers, and diversity of companies that would come. Obviously, the number of students is most likely at least an order of magnitude higher than in regular programs. So the number of companies is also going to be larger. It's not clear whether a regular placement, cell in any university can support such much larger numbers of thousands of students. So we do plan to have a separate placement.
There's one more thing I want to add, Aniruddhan, this, right? So what my experience with both teaching at IIM Bangalore and also in this programming and data science course, there's another very interesting element that happens in this, which I've noticed. So IIM Bangalore, if you start with, you see, IIMs, basically you have students who have worked for 4 or 5 years and then they come for management degree. And then you have students who just pass out of engineering and they come. So you have a combination of students, some of them who have experience, some of them who have no experience. And these people who have experience have a network. And what happens basically is that because of the class, the way it's organized and so on, they make friends and so on, they become friendly with each other. So suddenly an engineering student who has just passed out from engineering has access to the network of somebody who has been in the industry for 10 years.
Absolutely.
Okay. So this is incredible. Okay. Now I have seen the same thing happening here in our programming and data science. So we have about 20, I don't know what the number is, but I would suspect that about a quarter of our students in programming and data science are working professionals. These are people already with jobs, they are in companies that are being paid actually reasonably well. But they're still doing this degree because they wanted to get an IT degree, they couldn't, and now they're getting it. Or they want to learn something new or whatever, some reason they're doing it. Now, the other engineering students, if they do projects along with these people, they interact with these people through these discourse and other forums and so on, they can potentially network with these people who are already working and find themselves jobs even if we don't find placements for them. Because they have a network, right? They can talk to these guys and ask them, is there a job in your company for me?
Absolutely. That's
or
right.
do you know somebody who in your network group who is looking for somebody with my skills or something like that? So this is a beautiful vehicle, I think, for people to actually find jobs on their own, even if without us being actually agents trying to find the jobs. Of course, we have not yet gone through one placement round in the programming and data science, but I suspect basically that this is going to lead to jobs. I've seen it in IIM, this kind of networking, how it works. It works remarkably well in terms of helping people find jobs. And I'm sure it will work here also. So that's an element which you will not see in a regular engineering program, because you see in an engineering program, normal engineering program, everybody has 12th standard pass, no experience. All of them are studied together. They're at the same level of knowledge in terms of
that's right. The diversity is not there, right?
No
the diversity of
correct.
Of various aspects, right?
That's correct.
It is not there. That's right. That's right. That's actually a very important point. So, in fact, I would imagine that if students were interacting, somebody from, let's say, a new high school student who is part of this program has just so much to learn from another student who may have, let's say, 10 years, 15 years, 20 years experience, and is also undergoing the same course. There is just so much to learn, from that person.
Correct.
Right? It's just amazing.
And just a simple thing like you write a resume, you pass it to that person. Say,
that's right. Absolutely. That's right.
It's a value. So the guy can say, no, this is not the kind of resume that I normally see in my company. You could change this, make it look better like this. So feedback, which is so valuable. I mean, there's no substitute for that feedback, right?
Absolutely. Absolutely. That's right. So, okay. So I'll move on to one other question, more operational from the students. So I'll kind of answer that doubt. So the students were wondering if there will be a dedicated live class session for doubt clearing. If yes, then how often will we have such live interaction sessions? So what we expect is that, yes, indeed, there will be live class sessions. And depending on the course, it can take various forms. It can be a discussion. It can be a Q&A. It can take various forms. But the main idea is to make sure that the students feel comfortable asking questions, and getting them answered by the instructors. And we will have them as often as required. At least once a week is what I expect. Maybe more often. So that is what I expect for each course. And I think in a related question related to the lab work, students also wanted to know whether there will be teaching learning sessions on the campus related to lab. This is again related to what I was saying earlier about the lab sessions, the more advanced lab sessions happening on campus. So operationally, the way we plan it is that, at the end of every term, so we'll have 2 terms a year in this electronic systems program. And at the end of every term, we will have, in between terms, we'll have, in between successive terms, we'll have a couple of months of downtime. And during that time, we will, give an option for the students to come to IIT Madras campus for any 2 weeks out of those 2 months. So they will get a choice to come here, and we will kind of, help them, come up to speed and also do the more advanced experiments under the guidance of instructors on the IIT Madras campus. So there will be kind of discussion, help, instructor help, even for those, live lab sessions. So maybe this is a good question. I think I could have asked this question earlier, but I'll kind of ask it now to you, Dr. Venkatesh. So I wanted to get your kind of perspective on the lab component, or I guess there are, so in, let us say, a data sciences curriculum, the lab may take, a certain set of forms, maybe, writing programs, maybe debugging them, things like that. So in the electronic systems, we have, it's a slightly broader program in the sense that there are programming aspects as well, but there are also physical hardware labs, like digital labs, maybe FPGAs, and then on the analog side, op-amp based circuits, and so on. So I wanted to get your thoughts on, how important this is for electronic systems and how the industry views it as well.
No, it's very important. I mean, without actually touching and feeling an electronic system, how can you design one or work with one? So you have to be hands-on with these real things, right? The actual things. But I think the student, I mean, there is the potential that the student is little intimidated by the thought of building an electronic system, because just the thought that things can go wrong. In software, if things go wrong, nothing major happens. Okay. In the sense that you make a mistake, it gives you an error or something like that, some compilation error.
Right.
Then you can fix it. Nothing happens. Electronic system, something goes wrong, you see some fire and the thing blows up. Okay. Or so,
hopefully right? not in this.
you actually, I mean, you have
That's
to do that. I mean,
absolutely.
I'll tell you learn electronics only if you blow one system up.
Right.
This is my experience, right? Then only you know actually what's going on. So, you connect the wrong voltage to it, something you do, right? Absolutely. And then something happens to it. It starts getting hot or something, and then immediately you panic and you pull something. Now, so there is that general fear, right? That, okay, what if this kit which I mean, to some extent, I guess you're foolproof, idiot-proof, whatever it is. But I guess also these systems are not that expensive that if something goes down, you can always give them a help, right? I presume. So, right? So let them make the mistakes. Let them actually blow up things. You should not be afraid, I think. That fear you should cross over, and that comes only if you actually do it, right? When you first connect an electronic system to something else, things will not read. You'll not be able to read, right? The port will not read.
That's right.
You will not recognize the port. You don't know what is going on. So one of the biggest problems in electronics is, not electronics, I guess anything real hardware, is that, if things go wrong, you don't know what to do many times. You don't know where do you go and look for information that will help you fix this, right? So some support structure may be required so that the student is handheld, so that if at all they get stuck, then they can get unstuck. Something that you should tell them, try this. Why don't you try this?
Absolutely. So that's one of the most challenging aspects from our side, operationally, educationally, from that aspect, because there are, I guess, almost infinite number of ways in which you can break stop the circuit from working properly, right? And each one has its own, effects, right? Like you said, in some cases, some chip gets hot, some component gets hotter. In some cases, you may just blow a fuse. In other, a lot of things can happen. Yeah. You're right. So very, debugging is an art by itself and is going to require a lot of, hand-holding, especially in the initial labs. I do expect it. You're absolutely right.
And that's the process of learning. I mean, that you have to go through that in order to learn.
Absolutely. Yeah. Absolutely. So, yeah. Okay. So I guess I'll wind down with one last question. So this is related to higher studies. So we are getting a lot of, questions about whether, students here, will be able to do higher studies. From our side, we are very clear, right? So there are enough electives in the program, right? That allows the students to, do enough electives. So for example, if the student wants to do higher studies in India, they need to write the GATE exam, let's say in ECE. So they will have to build up skills in communication, in semiconductor devices, which are not core courses in a course such as this, which is an electronic systems program, right? So I guess I think the students would love to hear your thoughts, right, on higher study opportunities for graduates of this program.
So I presume it's a 4-year program. So anybody who has done this BS program would be able to apply for, even if they do, well, of course they can write GATE, they can try to write GATE and get into a program in India, but they could apply also for a master's degree anywhere in the US or anywhere else.
That's right.
So it would be, it's a recognized undergraduate degree. So they can apply and go anywhere for higher studies. So presumably that is there. So it doesn't preclude any pathways, I think. And in any case, I would say that, there are many students who do their undergraduate studies in, say, mechanical engineering, and then they decide to do a master's in electrical engineering. Of course, in India, it's a little more difficult because the GATE exams are very specific. People do go abroad and do all those kind of things, or do computer science or something like that. So nothing stops you from actually learning this and then trying to do something else. Of course, if the distance between this and that is very high, then those bridging courses you have to do on your own, I guess. That's what I think makes sense. But so it's not a showstopper or a roadblock or anything is there, right?
Right.
Because you did this degree, therefore some options are precluded suddenly, right? That is not there. That's how one has to look at it. Yeah.
Right.
But of course, it's not going to be a cakewalk. I mean, I would say that even if you did an electronics course from any engineering college, then it doesn't mean that you can write the GATE exam. Right? You still have to do a lot of work to write the GATE exam. It's a complicated,
very competitive exam.
A competitive exam, yeah. So that perspective, I think, just because you did this program, it's not going to put you at any disadvantage. I don't think so. Yeah.
That's right. Okay, so I think we are coming to the end of the program. So I'll hand it over to Girish to kind of conclude the program. But before I hand it over to him, I wanted to thank Dr. Venkatesh again for joining us today for this interaction session and really, enlightening us on various aspects right from the industry to his experience with the data sciences program to, the skills of the students and so on. Thanks a lot, Dr. Venkatesh.
My pleasure.
I'll hand it over back to Girish.
Thank you, Professor Aniruddhan. Thank you, Dr. Venkatesh. It was a wonderful session. You spoke about a lot of things about the industry, the skills, and also the curriculum and so on. We look forward to more and more such sessions. Of course, this is just the second interaction session for all the participants who are watching this. Please note that there will be more and more sessions, interesting sessions coming up. And please watch the space. And this interaction session will also be available on YouTube. You can watch it whenever you want. And please do send your queries if you have any questions. Please do send us email, and we will answer all the questions. Thank you so much. Thank you, Dr. Venkatesh, and thank you, Aniruddhan sir. And have a great evening. Thank you so much.
Thank you.
Thank you.